Hello, and welcome to this unit about probability calculations. In this video, we will begin with some general concepts that we will need throughout the unit and will be useful for understanding what comes next about more advanced ideas about probabilities. So firstly, we will begin with some definitions. First of all, we need to talk about what is an experiment. An experiment is a process that has an outcome and cannot be predicted in advance with certainty. We cannot use mathematical formulas or equations to know whether something is going to happen, yes or no. So there is some uncertainty in this outcome, and there are several options that we can consider. The set of all these options is known as the sample space, as you can see here in the second definition of the slide. The set of all possible outcomes of an experiment is called the sample space of this experiment. So if we can imagine throwing a dice, for instance, the sample space would be the set of numbers from 1 to 6, because this is the set of feasible values that we can expect to obtain as a result of these dice. And then we would be talking about the probability of obtaining 6 or obtaining 2 and so on. Each of these subsets of the sample space, probability of obtaining 3 or 4 or 5, it's known an event. But we could define other events, such as, for instance, the probability of obtaining an odd number or the probability of obtaining an even number. Each event has a link value of probability, but what we are defining now is the experiment, the result of obtaining 6 or obtaining 3. So that's the event, that's the outcome that we want to analyze. And for each of these outcomes, for each of these events, we will learn how to calculate the probability associated to this event. So, an event is a set of outcomes that we obtain as a result of this experiment, and there will be a probability that will be assigned to this event. Some examples of events, quite unlikely, would be getting struck by a lightning or, for instance, winning an Olympic medal. It's some event that may happen to us or no. And also we can consider whether it's unlikely or not that we will have twins in the future. So these are several events that may happen, yes or no, and we will learn how to compute the probability linked to each of them. So, to understand what is the meaning of an event, we need to distinguish between elemental events, compound events, sure events, and finally, impossible events. In this course, we will work only with elemental events, the one that's at the top of the slide. An elemental event is composed by only one element or result. So we will be talking about something happening yes or no. There are other type of events that are compound events, and they are composed of 2 or more events that happen at the same time, simultaneously. So it's something similar to an intersection of similar events. But these compound events, they are out of the scope of this course, so we won't be covering these compound events in this course. But it's interesting to know that they exist. There are other type of events that are sure events, those events that are we are completely sure that they are going to happen. Why? Because their set of outcomes, the outcomes they represent, they cover the complete sample space. So if you consider all possible options that are related to this event, they cover all potential options and alternatives that we could find as a result of this event. And finally, one impossible event is one event that cannot happen. So the set of elements that are included in this impossible event is the empty set. Nothing is included in this impossible event. Why? Because it's unfeasible that it happens. Some useful definitions that we will use in this course. One of them is the complement of an event A. Notice that we are using uppercase letters to refer to events, and we use A bar, we use the name of the event, such as it was shown here. We are referring to event A, and then we use no A to refer to the complement of A. The complement of A includes everything different of A. So that means everything that's different from A. So it's the difference between the sample space, which is the rectangle in the slide, and the area defined by the event. So no A is usually represented as A bar. Also, we can define inclusive events. Inclusive events mean that we are working with two events, such as it is the case in the slide, like A and A. And as you see here, A is a subset of F. So that means that E is included in F. E is included in F. And both are included in the sample space, which is bigger, and this is represented by S. So, linked to each of these events, we can work with the idea of probability. Probability refers to the chance that one event that has some uncertainty will happen or no. As we said before, we cannot determine exactly with mathematical formulas, we cannot compute deterministically what's going to be the probability that something happens. So this probability is a number that is included between the interval 0 and 1. 0 for impossible events and 1 for sure events. Any value of probability should be outside of this interval. So for any event A that we can define, its value of probability should be included between 0 and 1, both included. So this probability of A is defined as the ratio of all possible favorable cases. That means all situations, all conditions where the cases accomplish the condition that's defined for the event over the total number of cases that are defined for the sample space. This is how we compute the probability of event A. So, in the end, the probability is a continuous range that starts in 0.0 for impossible events and finishes in 1 for sure for events that are certain that they will occur. So any value of probability should be included in this ratio. We will refer to P of A within parentheses as the proportion of times that event A will be observed, will happen in the future, in the long run, if we were able to run again and again this sampling design, if we were able to try and replicate experiments over the same phenomena, the probability of A, and this is expressed as P of A within brackets, is the proportion of times that we expect to observe event A in the long run. So that's the probability, that's the chance that something is going to happen in the future. With this, I finish this brief introduction to some general concepts to probability calculations. I hope you enjoyed the video and join next video. Thank you.